Good morning, students. So, how are you all? I hope you are all doing good. So, let's start today. And today, the first topic that I am going to present with you all is soil and crops. Okay, soil and crops. Different crops need different types of soil. Okay, there are so many different crops. To grow different crops, we need different types of soil. For example, let us talk about rice. To grow rice, we need clay soil with some organic matter. Because you know why? Why clay soil is preferred to grow rice? It is because to grow rice, it needs more water, and more water can be retained only by clay soil. That's why clay soil is mostly preferred to grow rice. If we talk about wheat, to grow this wheat, both clay soil and loamy soil are suitable. Now, to grow the wheat also, it needs more water. Okay, and more water can be held only by clay soil and loamy soil. Okay, so that is why clay soil and loamy soil both are preferable to grow wheat. However, loamy soil is the best one. Okay, to grow wheat, loamy soil is the best one because loamy soil is the most fertile soil. Now let us come to cotton. Now you might have seen cotton plants. To grow these cotton plants, we need sandy loam soil. Because to grow cotton plants, the more water is not needed. What the cotton plants need is more air. And sandy soil can retain much more air than the clay soil. That's why sandy soil is mostly preferred to grow these cotton plants, because sandy soil can retain more air. And let us talk about different kinds of pulses. Different kinds of pulses like grams, lentils, they can be grown in well-drained loamy soil. So these are some of the requirements of soil for different kinds of crops. Now let's come to the properties of soil. Number one, soil contains air. Okay, soil contains air. If we talk about sandy soil can contains more air, but clay soil contains less amount of air. Okay, so some soils can retain more air, some soils can retain less amount of air, and sandy soil can retain much air because in sandy soil the particles are very large, so the spaces are also very large. So due to large spaces present in sandy soil, sandy soil can retain more air, and due to small spaces between clay soil can retain less air. Okay, so number one property is soil contains air. Number two, soil contains water or moisture. Any kind of soil, you take any soil, from your surrounding, all contains some definite amount of water or moisture in it. Okay, you can take any kind of soil. All soils can contain a definite amount of water in it. Number 3, soil can absorb water because it is porous. Soil can absorb water. Now you know that soil contains some pores or spaces between the particles. So due to the presence of these pores or due to the presence of the spaces between the soil particles, soil can absorb water. Okay. Now some soil can retain much water, but some soil can retain only less water. Now can you tell me which kind of soil retain much water? Yes, clay soil. Clay soil can retain much water because the spaces present between the clay soil are very small. So every soil can absorb some amount of water. Some soil can retain more water and some soil can absorb less water. Okay, now let's come to the property number 4. Soil allows water to percolate. Percolate means pass down. Now some soils can percolate more water and some soil can percolate less water. Now can you tell me which type of soil can percolate much more water through them? Yes, sandy soil can percolate more water because the sandy soil, the spaces between the sandy soil is very large as compared to other types of soil. That's why due to large spaces, the water can percolate easily through sandy soil. But through clay soil, where the particle spaces are very small, the percolation rate is very low. Okay, so these are the 4 properties of soil. Number 1, soil contains air. Soil contains water. Soil can absorb water and soil allows water to percolate. Now in the property number 2, the property number 2 says that soil contains water. Any soil contains some amount of water in it. Okay. So now we have to find out the amount of water which is present in soil. Now let us take a look at this question. Roman is a boy. Roman has collected some soil from his surrounding. From the surrounding, Roman has collected some soil whose mass is 200 gram. Okay. After drying up the soil under sun's heat, the mass of the soil becomes 170 gram. So initially, the soil which he has collected, the weight was 200 gram. The mass of the soil which Roman collected initially was 200 gram. But later on, after drying up the soil under sun's heat, the weight becomes 170 gram. Okay? It means the weight reduces, the mass reduces. Initially the mass of the soil was 200 gram, but after drying up the soil, the mass reduces to 170 gram. Why do you think so? Why the mass reduces after heating up the soil? Because we know that soil contains some amount of water. Okay, So when the soil was heated under sun, the water which were present in the soil gets evaporated. Okay, the amount of water gets evaporated. That's why the mass becomes less, the mass got reduced. Now we have to find the mass of the water which was present in the soil initially. We have to find the mass of the water which got evaporated. Okay, so we have to find out the amount of water. Therefore, mass of the water in soil is equal to 200 gram minus 170 gram equal to 30 gram. So 30 gram, this is the mass of the water which was present in the soil initially, or you can say this is the mass of the water which gets evaporated due to sun's heat. Okay, now if you are asked to find the percentage of water in the soil, now you have to convert this amount of water into percentage. Percentage of water in soil equal to mass of the water divided by original mass of soil into 100. So here you have to put the mass of the water, that is 30 gram, and original mass of soil, that is 200 gram into 100. Now you will get some percentage, that will be the percentage of water which was present in the soil. So this is homework for you, you have to show me. Okay, now in the property 3 of soil, you observe that water absorbs some amount of that soil absorbs some amount of water. Okay, now how to find the amount of water being absorbed by the soil? So we have to find out. We know that soil absorbs some water, but how much water is absorbed by the soil, that we have to find out now. So you can see this is a measuring cylinder. Okay, this is a measuring cylinder. So in this measuring cylinder, you fill up the cylinder up to 100 ml. You fill up the cylinder with water up to 100 ml. Means you are taking water of 100 ml volume. Okay, now this is a beaker, and this is a funnel. In that funnel, you are taking some soil. They are soil, 50 gram soil. Okay, the mass of the soil is 50 gram. You are taking 50 gram soil. Now what you have to do, with the help of a dropper, you collect the water from the cylinder and pour the water in the soil. When you pour the waters in the soil, then some amount of water will absorb by the soil and some water will be percolated through this funnel. Now what we need to find is how much water gets absorbed by this soil. Okay, so the mass of the soil is 50 gram. Mass of the soil is 50 gram. We are taking 50 gram soil. Total amount of water is 100 ml. So we are taking 100 ml water. amount of water which is left in the beaker is 80 ml. Okay, we are pouring 100 ml water into this soil, then some amount of water gets absorbed by the soil and some amount of water is percolated from this funnel, and whatever the amount being percolated will be collected in this beaker. Okay, so the amount of water which is collected in the beaker is 80 ml. Then how much water is absorbed by the soil? The amount of water absorbed by the soil will be 100 minus 80, it will be 20 ml. Okay, initially you poured 100 ml water and left in the beaker 80 ml. So what happened to the remaining water? The remaining water was absorbed by this soil. And what is the amount of the water absorbed by the soil? That is 20 ml. 20 ml water was absorbed by the soil. Now what will be the percentage of water being absorbed? Now you have to convert this amount of water which is absorbed by the soil into percentage. So to find out the percentage of absorbed water, what we have to do, just put the values in this formula. Here mass of the water absorbed, and mass of the water absorbed will be what? 20 ml. Okay, now we have to find out percolation rate of water. Percolation rate means the percolation speed. By how much speed the water can pass down through soil, that we have to find out. Okay, so let us take a question. 200 ml of water takes 40 minutes to percolate through a soil. In 40 minutes 200 ml of water can percolate. Okay, in 40 minutes 200 ml of water can percolate through the soil. Now what will be the percolation rate? What is the percolation speed? Okay, so percolation rate can be found out with the help of this formula. Volume of water percolated divided by time taken for percolation. And we know the volume of water which is percolated is 200 ml. So we put here 200 ml. And time taken for percolation was 40 minutes. So we write here 40 minutes. If we do this, then we will get 5 ml per minute, 5 milliliter per minute. So this is the speed of the percolation. Okay, this is the percolation rate of water. So now the topic is soil erosion. You all know, you all have a little idea about soil erosion. So let us discuss what is soil erosion. Soil erosion is the removal of the topsoil from land by wind or water. We know that there are 3 layers of soil: topsoil, subsoil and substratum. Okay, so in soil erosion, the topsoil, the top layer of the soil is removed by some environmental factors like wind or water. Okay, so that removal of the topsoil from the land by wind or water is known as soil erosion. And what are the causes of soil erosion? The main cause of soil erosion is cutting of trees. When large quantity of trees are cut down, when trees are being cut for building purposes, for getting firewood, for making paper, the trees are being cut. Okay, so due to cutting of trees, what happens? The soil cannot be held by the roots of the plants. Initially, the soil was holded. The soil was being holded by the roots of the trees or plants, but after cutting down the trees, there are no more roots present in the soil, so soil become loose, and that's why due to rain water or wind, the top layer of the soil gets removed. Okay, and soil erosion occurs. Now, in your books, the effects of soil erosion are given and how to prevent soil erosion. You have to study from the book, okay? And if you get any confusion there, you have to ask me, okay? And the last topic that I am going to discuss is soil pollution. Okay, so you know already what is soil pollution. When the soil is contaminated with waste materials, then this is known as soil pollution. Okay, the contamination of soil with waste materials like plastics, industrial waste, pesticides, etc. is called soil pollution. Okay, now what are the effects of soil pollution? There are various effects of soil pollution. Okay, if we dump the plastics or polythenes in soil, it is causing harm to our environment and to many living organisms. Many living organisms used to eat those waste, as a result of which they die. Okay, and so there are so many bad effects of soil pollution. So you study it by yourself. It's given in your book in very detail. Okay, now this is the prevention of soil pollution. How to prevent soil pollution? If we are using some polythenes or plastics, then we have to throw it in a dustbin only. So you study these effects of soil pollution and prevention of soil pollution from your book. If you have any doubt, then you ask me. Okay, so this is the last topic. This is the last topic of your chapter soil.